Hello. Today I'll show you several examples how visual LLM could work with financial data, how to extract financial data, not from typical invoice documents, but from the information that you can find online. And instead of reading text, scrapping data, you could take, for example, screenshots and with the help of visual LLM extract data directly from the screenshots. And I'll be using a couple of examples from MarketWatch and from Financial Times. And I'll be showing you how you could get stocks data out of the screenshots. So first example is a chart for, I think this is Nasdaq data, and we are fetching data directly from the screenshot. So in the query, I'm passing the JSON schema to hint LLM how to construct the response and to tell LLM what data I want to extract from the screenshot. So I pass this JSON schema here and say that I would like to get current value, change percentage, last updated, previous close, day range minimum, maximum, and the difference for the week range. And once this request is executed, then this is the answer we get. So we can see that it works great. And now if I try to re-execute it, I'm running, this is the private Hugging Face space. This is the Sparrow backend, and I'm running it on Hugging Face 0 GPU. And I could see that it executes here, and then I could, from the log, I can see that the checkpoints were loaded and the result was produced in some 20 seconds. But this is the basically free shared GPU accessible for Hugging Face Pro subscribers, and you don't need to pay any extra. It just costs $9 per month. It's excellent for the development and testing purposes. So we get this data, and from this kind of very unstructured layout. Another example, this is from Financial Times, S&P 500 index. And here I also provide a list of elements to fetch, like index name, price, change, shares trade, and then change percentage, and week change low, week change high. And now if we execute this, then we can see that this 0 GPU loads the checkpoints, and then it should produce the answer for us. And this layout is different than from the previous one, and using the Qwen2 7B model, in this case not Quantize but the original model I'm using, and it's able to extract data very well from this kind of layouts. And let's take a look, for example, for the today change percentage. I got 2.53, so this is the value. And for the today change, we get 146.28. This is the value. And for the shares traded, for example, I want to get exactly the value as it is, not a number, but with billion. BN. So I hint here in JSON schema that for the shares traded, I want to get string. If I put 0, this means LLM would understand that I want to get a number, and it would return 4.19, for example. And in this case, I tell LLM that I want to get a string, and I get string as expected. And for the week range, I get low and high values correctly as expected. Okay, and another example is table. This is the Switzerland stock market information here, and in this case it's slightly different JSON schema. Instead of getting a list of elements, we're getting an array of elements. So we specify here that with the square brackets that we'll get array of elements. So we get listing name, then we get listing code, and both are under the same column, just under different rows, and Qwen2 is able to process this kind of request as well, which is fantastic. And then we get last, which is the number, then we get the change, which is the number again, and then we also instruct that we want to get change percentage, and we want to get it as a number too. And finally, volume, we want to get a string, because some will be million, some will be 1,000. In theory, I should test maybe we could instruct LLM to auto-convert here. We can provide a hint saying we would like to auto-convert the number with million or with 1,000 into the final number. But for now, here just to instruct to return value as it is without any conversion, because I can do conversion myself later when I'll do post-processing for the JSON. Okay, so we execute. And now again, we run it on 0 GPU, and if you check here, we can see model checkpoints are loaded, and now actual execution happens. So this table is processed, and we should get the result in few seconds. This is more challenging example because it's a table, and we have for the same actual row, we have data in multiple lines, like here for the name and for the code and for the change and for the percentage. And we got back result. So we see that name is correct, code is correct, last value is correct, change is correct, and percentage is correct, and volume is correct. For the second one, it's also correct. And the good thing when you test the accuracy of the response from LLM, based on my experience, is good always to cross-check the last value, because often in the middle LLM may confuse something and the last value can be incorrect. If the last value is correct, then almost certain all other values are correct as well. So here we get Sonova Holding, this is the code, this is the last, this is the change percentage, and actual volume. So everything is correct. So thanks for watching, and my point of this video was to show you how you could use Visual LLM to handle non-typical information, not some information from the documents, but information from the screenshots, and specifically stock information from different sources like Market Watch or Financial Times. So thanks for watching, and see you next time. Bye.